All right, for most of chapter 3, we've been investigating attraction, and we're going to continue to investigate attraction and its effect on phase change. For the rest of the part, we're going to be thinking about stability and change, such as when a substance phase remains stable and when it changes. So, question 89 is our new investigation question. This new question says, how does molecular attraction affect whether or not a phase change will occur? Pause the video, copy down this new investigation question for question 89 in your notes. Okay, question 90 is a fill in the blank. So we know that the molecular attraction of a single substance never changes, but it can be different for different substances. This difference allowed rubbing alcohol to evaporate, but not water. So pause and fill in your two blanks from the bolded words. Okay, this one means that like water, the molecular attraction of water never changes. The molecular attraction of the rubbing alcohol never changes either. But just because the molecular attraction for water never changes and the molecular attraction for rubbing alcohol never changes, that doesn't mean they have to be the same. They can be different. But for each one, it doesn't change. They can be different from each other, but you can't change it later on for water or change it later on for rubbing alcohol. All right, next you're going to use what we've learned about attraction to make and test some predictions about what will happen in the sim. So let me go into slideshow because we got a video to watch showing a specific feature of the sim.
Let's use the phase change sim to explore molecular attraction. We'll select substance A and turn off gravity. Let's start the sim. If we drag a molecule away, it gets pulled back to join the rest of the group. We know it's not gravity that is pulling the molecule back to the group, since we turned gravity off. This behavior is evidence that the molecules are attracted to each other. This sim will help you gather more evidence about how attraction affects phase change.
All right, so just like how magnets don't need gravity to snap together, molecules don't need gravity to be pulled towards each other. The molecular attraction still exists even without gravity. So you and a partner will compare different substances, and you're going to compare results as you experiment with these different substances. For these experiments, you should leave gravity on. That video that we just watched was just to show that gravity doesn't control if something's a solid, liquid, or gas, but you want to leave gravity turned on because it makes it easier to distinguish between solids, liquids, and gases. Before each test, you're going to need to make a prediction about the substances that you're dealing with. For test 1, you'll prepare each substance by transferring energy in to reach the highest amount of kinetic energy. Then you'll slowly transfer energy out. For the second test, test 2, you'll prepare each substance by transferring energy out to reach the lowest amount of kinetic energy. Then you'll slowly add kinetic energy back in. So let's look at our instructions. If you click on 91 and open it up, it'll take you to the sim. I think I'm actually, sorry, my button got covered up that I need to switch between the different parts of the sim. So let me go back here. All right, your instructions start right here where it says exploring attraction in the sim. Launch the sim, then follow the instructions below to test the investigation question. How does molecular attraction affect whether or not a phase change will occur? As you complete the activity, answer the questions provided. So here is test 1. You'll be dealing substance B and C. The first partner should test substance B while the second tests substance C. I don't care if you divide and conquer or if you both test B and both test C, just to make sure that you agree on the results. When you're finished, compare the results. Note substance B has a medium molecular attraction while substance C has a low molecular attraction. So first of all, read this, make a prediction, follow these instructions, answer number 4. Then we come to test 2, where we're going to test A and B. Same thing as before, make a prediction, follow the instructions, answer the questions. When you are done with test 1 and 2, I want you to go to question 92, which is a follow-up question. It says two substances, both solids, start out at the same temperature. You transfer the same amount of energy into both solids, but substance 1 becomes a solid before substance 2. Based on this evidence, which substance has a stronger molecular attraction? Explain your answer. So go ahead and follow the instructions on 91, complete the sim activity, and then answer question 92.